Okay, so the next one is application of multiple integral. Okay, so we're gonna take a look on the application of double integral first. Okay, so based on the slide given, okay, this is basically the terminology that will be considered for the application of double integral. We have lamina, density, mass, moment of mass, center of gravity, and centroid. Okay, so you can take a look of the terminology by your own. Okay, so let's take a look um, on double integral. Which one is represent the mass, the moment of mass, center of mass, centroid, and so on. So by definition, if delta is a continuous density function on the lamina corresponding to a plane, so the things that you calculate is a mass basically. Okay, so we have delta here. So previously we have, let's say we have like this, right? Okay, a function in terms of phi, and you have dA. Okay, so basically this one is represent the mass. Okay, the mass of the lamina. So here given function represent the density. Okay, it's delta here. Okay, so whatever that you calculate basically represent the mass. Okay, and a moment of mass for a function of two variables can be divided by 2. Okay, moment of mass about the x-axis, and the second one is moment of mass about the y-axis. Okay, so this one represent the moment of mass represented by m small x here. Okay, take a look of this one. You have to memorize all the formula. Okay, so moment of mass about the y-axis is given by this formula. The next one is center of mass. So basically center of mass is whatever that you calculate for moment of mass divided by mass, you will get the center of mass. Okay, so if the density is constant, so the center of mass is called as centroid of the region. So if the question asks you to find the centroid of the region, okay, you have to remember that the density is constant. Okay, and the last one is moment of inertia, also called as second moment. Okay, tendency to resist a change in the rotational motion about an axis. So basically moment of inertia, it comes from this one, moment of mass. Okay, so let's take a look at this one. Okay, so moment of inertia about the x-axis is represented by I. Okay, so I. So let's take a look okay, let's say we have moment of mass here, moment of mass. Okay, we represent mx, my, right? Okay, so we have y, sorry, double integral y here, since one is over for x, y, delta, which is the density, and dA, so either dx dy or dy dx. So the moment of mass about the y-axis is equal to double integral x here, so delta x y dA. Okay, so for second moment of moment of inertia, second moment here represented by I. Okay, Ix is equal to y squared delta xy dA. Okay, so moment of inertia for x-axis is this one. If you take a look, basically it come from here. Okay, we squared for y. Okay, so if moment of inertia for y is equal to, from here, x squared delta xy dA. Okay, we have one more, and the moment of inertia is moment of inertia for z-axis. So basically moment of inertia for z-axis is a summation of moment of inertia for x and y. So that's why we have x squared plus y squared time with delta time with dA here. Okay, so basically if you memorize this one represent the mass, the moment of mass, center of mass, is enough. Okay, so moment of inertia basically come from here. Okay, since the formula is not given, so you have to memorize it by your own. Okay, so I give you example. Basically the application is you have to understand the terminology and the formula given. Okay, so which one is represent whatever that we have learned previously in double integral, either for Cartesian or polar coordinates. Okay, is represent what? Which one is represent the mass? Which one is represent the moment of mass, center of mass of the given lamina, of the given surface? Okay, so the question, basically the final question will ask you focusing on application of double or triple integral. So you can take a look of the question that I attached in this slide. Okay, so the basic idea still same. You have to sketch first. Okay, sketch first, and then decide which formula that you gonna use to answer the question. Okay, so this one, the first example I give in the slide is on a Cartesian coordinates. Okay, so you can take a look on the second example is for polar coordinates. Okay, the basic terminology is still same, but then we convert y and x in terms of polar coordinates. Okay, so you can take a look at the example. So we will discuss more when we have class later. Okay, thank you.